Hello, everyone. I'm here to talk about geospatial analytics with GeoParquet. I'm Rekha Khandhadia. I'm a solutions architect for Crunchy Data. And if you don't know Crunchy Data, we are Postgres, PostGIS products company, you can call. We provide a lot of different services and things like that, and we have a lot of products. But today, I'm here to talk about GeoParquet, Geospatial. So what to expect, right? Today, I want to talk about my experience. Sorry, am I moving away? Okay. My experience about, GIS data pipelines. You will see some traditional diagrams and the challenges that I've faced. And then I'm going to deep dive into GeoParquet because I started this journey and I wanted to really lay it out what does it mean, and some of was covered in the previous session, but so this will be a little bit of repeat. And then I'm going to introduce to you Crunchy Bridge Analytics. So this is, I'm based out of Detroit, so I worked with a lot of automotive and healthcare industry. And this is a typical GIS because they are, at the time when I was helping them, it was on-prem. So you can see, you have big data, connected vehicle or your EDI claims coming through, and you had different formats like GeoJSON, shapefiles. Those are your data sources. That data sources you transform using different tools, GeoPanda, PostGIS, and you orchestrate your data pipeline with if you're using big data, Scoop and Hadoop and things like that. And you store your data, and then you visualize your data with different tool sets, right? This is a typical GIS thing. If you look at the cloud, you will see all the cloud services that do that as well. So what are the challenges, right? Diverse data formats, scaling and processing of large data sets, orchestrating a lot of failures, right? You need a team with a lot of different tool skill sets. They need to understand different, all the paradigms of your data pipeline, right? A lot of data movement, data duplication and transformation. Rules change, and it takes longer to implement, right? People will say, well, cloud it will make a little better, but your business wants more, right? And you're constantly struggling with new requirements and making your developers want to, deliver faster, right? So then, naturally you're thinking, can I streamline? Can I modernize? What is it that I can do differently? As I started to evolve, right, I came across this keynote by Chris Holmes, and I learned a lot. I must have listened to this at least quite a few times, right? And there he talks about all the geospatial data infrastructure. But all of my data was in vector format, right? So I picked up GeoParquet from here, and that's where my journey starts. So what is GeoParquet, right? I wanted to lay out a map that I can really make everybody in my team understand what it is and how we are going to leverage that, right? It's an open source. You heard columnar store versus row, right? Compression, encoding. So when you think about encoding, think about your type mapping, right? You take, cities and map to a key, and then that's what is used within your Parquet, right? Efficient storage and compression, that's also another thing that's there. It supports gzip, Z-standard, and you're going to see a little bit more, right? It's a high performance, and it does predicate pushdown. Predicate pushdown is you are pushing your filter condition near where your data is, right? So what's happening is you're not moving your data into memory and then filtering, and 90% of the data is you don't need. This is where the optimization and it brings up, right? Um, and then you have widely supported analytics tools. Yeah, it supports complex and nested data types, and you will see what it means, right? Nested, you can say record type, like address or an array, right? Now, Parquet, this is all the blue stuff that I've explained. It's in Parquet. Parquet came up in 2011, right? So it's been like 13 years. And in 2021, OGC introduced GeoParquet. So they leverage all of the Parquet and added support for geometry columns. There's two things here. A geometry column you have in well-known binary format, and you have a concept of bounding boxes. And you're going to see how all that fits in. So here is an example, right? This is from, Cloud Native GIS site, right? And here you see a concept of row groups. Row groups, you need to think in terms of old time table partitions, right? Horizontal partitioning of your data. And then you have column chunks. Because it's a columnar database, you have continuous store of your column data in a memory. And then you can see the point, right? It shows you the geometry here. It's stored in well-known binary format. And all of the stats and file metadata is stored within the Parquet file, right? Now, I wanted to understand a little bit more, right? So I took an OGR to OGR tool set, and I took my county shapefile and converted into Parquet so that I can see what this is, right? Here you can see your geometry column, right? It says it's well-known binary format and also shows you the bounding box and also gives you a type, right? It supports all the normal types that you have, right? And here is the statistics and the version of the GeoParquet that your file was made in, right? And so now this is a small file. How does it really help me if it's a big file? So I took Overture map, it's very common right now, and places, and I said, okay, show me how this is going to look, right? So here again, you can see the geometry. It's well-known binary. It's a type point, and it shows you the bounding box. And you're going to see what this really means. And here, you can see additional, how many rows does this row group have? And, how many row groups, this file, sorry. How many row groups does this file and the version, right? You need to understand a little bit more deeper so that you can understand why certain things are working the way they are working. So now we talked about file metadata, right? So the reason I'm highlighting this is because you can see in the file metadata, it captures minimum and maximum values of each of these fields. This is where your filtering condition is pushed to the downstream process, right? This is the pushdown predicate performance that you're gaining over here, right? And you're going to see how this works. So when you have a query that you're doing that, it reads the footer file, okay? It finds out what the row groups are. Then it's going to apply additional filter. So I want to do a query on Michigan, and I give the bounding box of the Michigan. It's going to take those row groups that it needs. So you're only selecting the data that you need. Then it also does a column chunks, right? If I have additional filters like price, this row group have this price, and then it selects those. So, and then of course, it gives you the data back. Okay. So maturity of GeoParquet has really, started some phenomena that we have been all waiting for, right? A lot of open data sets. You can see orchard map, source, cooperative, AWS as a session, a lot of Microsoft, right? All of those. Also, it has a lot of support softwares. There is also tool sets to convert from one format to another, and then just talked about OGR to OGR. And the big one also comes now is the OLAP databases, right? And DuckDB is also has a lot of, and for all good reasons, a lot of attention and a lot of usage that's been happening, right? So let's see what DuckDB is, right? It's an open source. It's simple installation, single process, right? It's an OLAP database. It queries, this is where the thing is, it queries the remote files, right? GeoParquet, CSV, shape files, you have it out there, right? Most of our county shape files are out there for us to take, right? It has a spatial extension, SQL interface, right? Parallel execution, in memory, and fast analytics, right? We will look at that, right? I am Crunchy Data, right? And I am Postgres and PostGIS. And I'm going to Crunchy. Okay, what are we doing about it, right? I mean, this is what I've been waiting for. So we introduced Crunchy Bridge for analytics, and let's see what it is, right? In April. So Crunchy Bridge Analytics seamlessly integrates Postgres and PostGIS, seamlessly integrates DuckDB. You can query remote data sets, GeoParquet, JSON, shape files, and it creates via a foreign table, and we will see that. It supports complex data types as well. You have an easy way to data import and export, because Postgres, you have a copy and things, same process, same tool sets, right? We do vector execution, parallel processing, and caching. So, all this looks at it, but I am a pictures person, right? And I want to see how it really would work, right? So I have a client that is connected to Postgres, right? And seamlessly it's going to integrate with DuckDB. I'll be able to query S3 data and bring it back to that. So I want to see an example, right? So we create here a foreign table of overture, transportation, road data. All we do is take that S3, connect, and it creates a structure. So how does this structure really look? And I said it's seamlessly connecting with Postgres and PostGIS, right? You can see here there is a geometry column, right? And you can see here the bounding boxes, and you can see your structure, right? A complex structure, because this is where the bounding boxes and things are. And this is important to us. And a lot of all the, you can see text and normal data types it will create. I want to see how does the bounding box look like. This is what it looks like, right? It is a column, it's a complex structure, so you can see minimum, maximum, and values of it, right? Again, I want to see it. I'm a hands-on person. I work with a lot of development team. I want to see it, right? So I was told at the last minute there's no Wi-Fi. So I created screen recording, right? And I am going to create foreign data tables for all the orchard map, GeoParquet files, buildings, places, roads, and I want to see GeoJSON file. I want to take US shapefile, and US fires was one of them. And then I want to look at the CSV file as well. And this is, so I'm going to be next, and you're going to see the screen recording, right? And I took all of it, and I'm going to run this. Is it running? Yes. So it is creating all of the foreign data tables, and you can see it just took minutes. Okay. Oh, I need to go harder. Okay, so now that I have a foreign data tables, I want to be able to query it because I want to count the records. I want to visualize how it looks. I want to use SQL interface, right? I want to be able to do a query like I'm in Traverse City. I want golf course. I want to see, is there a coffee place nearby? Count roads. I'm automotive. I supported, road network applications. So I want to see how many roads in Michigan. And then I want to visualize the data in QGIS. Again, GeoJSON, you're going to visualize, you're going to count fires in Michigan, visualize the fire locations, right? Here again, it's going to go very fast. Here are the counts, right? And then I want to look at 10 orchard maps, and you can see one of the things is it's well-known binary geometry, so it doesn't have an SRID, so that's why you don't see in the map. Here I have transformed SRID, and you can see it now. This is pgadmin. I'm showing that in Postgres, right? And you can see those as well. Wait, goodness. Yeah. And then I wanted to count roads in Michigan. There it is. Okay. Now I want to take Traverse City, coffee shops, and golf courses and see where there is closest. I want to find them near 1 mile, right? And that's the query. I'm running this in QGIS. This is the distance query, which is very common in our geospatial stuff. Then, of course, I wanted to style it in QGIS, right? I wanted to show, because it's very hard sometimes when it comes, it's a small bullet points and things like that, the points. So, and I wanted to label it. So all of this recording is done while I was doing it. So, and it's fast, right? DuckDB offers the option of a very fast performance, right? And you can see that it's happening. I could have skipped it, but I thought it was. Wow, it's taking longer than I thought. All right. So here you can see all the formatting. You can see all these golf courses and the coffee, they're within 1 mile, right? So there is another queries that I am running. I have Austin Airbnb data that I took from Hugging Face, and I want to find a price between 100 and 250, right? And I want to visualize where they are. So pgadmin has an interface that you can visualize your GIS stuff very quickly, right? And this is all, even though it's a screen recording, it was running very fast, right? Here are another New Zealand, and there was just one record, but I wanted to do an experimentation with GeoJSON, how easy it is for me to take the data, right? And I'm showing if it's New Zealand, and to make sure it was New Zealand, right? Because you are taking the data set from outside, and you really need to know, right? Okay, it's almost 20 minutes. Okay, maybe I will just move on. These are fires in Michigan. The beauty of this is that you can also take materialized view within your Postgres and do it, right? It's like I'm taking the same data, I can create materialized view, I can create the gist index in PostGIS, seamlessly integrating with the tool sets, right? Same thing, here is a complex data type that we are taking. I want to see the speed, minimum, maximum, and roads in Michigan, right? Are there speed limits, all of those GIS things that we do, right? I wanted to see, here is an MV. I wanted to take all of the roads near a certain point within 5 miles of distance, right? These are normal things, but they take longer when we are trying to do it through an ETL pipeline, right? Here is your nearest neighbor query, right? Again, seamless integration. So let me summarize. We went into technical GeoParquet, low code, zero code ETL process. You can call it ELT, seamless integration with Postgres, PostGIS, visualization on QGIS and pgadmin. And one thing is, the number of skill sets that you need to do this came down so less. So when we are struggling to find right people and trying to give this is the tool that you can use. And, Postgres integrates with all your Python, Spark, and all of that. So thank you, everyone. And these are the credits. I give a lot of credits to people.